Japan's military tradition has always embraced technology, from the katana to today's cutting-edge fighter jets. Now, in collaboration with Italy, Japan is developing a sixth-generation aircraft to keep pace in the global arms race. With AI-assisted piloting, digital design, and advanced data sharing systems, the future of aerial combat is evolving. Imagine autonomous jets, virtual cockpit displays, and hypersonic weaponry reshaping warfare. Historically reliant on licensed designs like the Mitsubishi F2, Japan now faces growing threats from China, Russia, and North Korea. The need for an indigenous fighter jet has never been more urgent. Enter the I-3 concept, intelligent, information-driven, and integrated. The Mitsubishi FX is Japan's answer, built to detect and neutralize stealth threats with high-power radar, UAV coordination, and next-gen stealth. A powerful yet lightweight engine ensures agility, while modern sensors and laser weapons push its capabilities further. Can Japan successfully develop its own advanced fighter jet? Share your thoughts below. The IXF-91 engine prototype debuted in 2018, leading Japan's defense ministry to shift from the Tu-3 aircraft program to the FX, assigning development to Mitsubishi by 2020. A key reason for Japan's independent fighter program? The U.S. ban on F-22 Raptor sales. The FX, larger than the F-22, has earned the nickname Godzilla. Unlike older jets with hydraulics, it uses electric motors, maximizing space for weapons and enhancing agility. To improve stealth, the FX features a delta-wing design, radar-absorbing coatings, and an internal weapons bay for reduced radar signature. It also integrates serpentine air ducts, electromagnetic wave absorbers, and a lightweight carbon fiber-reinforced structure to minimize detection. Equipped with advanced sensors, the FX includes an upgraded ASA radar, passive radio frequency sensors, and infrared cameras, similar to the F-35's APG-81 radar. Its cockpit features a digital interface with a large touchscreen and HUD for superior situational awareness. Could the FX redefine air combat? Share your thoughts below. To prevent the aircraft from overheating due to the heat generated by its high-tech equipment, engineers installed a small heat transfer system inspired by the vapor cooling cycle. This system assists the liquid cooling mechanism and the aircraft's air cycle. Mitsubishi has also paid special attention to the XF9 engine, which does not require additional cooling. Its slender design, with an inlet 30% smaller than the GF10 engine used on the F2, makes it well-suited for a stealth aircraft. The FX engine utilizes vector thrust technology, allowing for adjustments in exhaust flow direction. This feature significantly enhances maneuverability, enabling the aircraft to perform complex maneuvers at high speeds, giving it an advantage in intense dogfights. With the ability to generate 360 kilowatts of power from two XF9 engines and a 3D thrust, vectoring nozzle capable of adjusting the thrust angle by up to 20 degrees, the FX achieves high maneuverability. This capability has transformed the aircraft into a true silent killer. It can achieve supersonic speeds without using afterburner mode, a feature commonly found in fifth-generation aircraft like the F-22. This not only conserves fuel but also reduces thermal signatures, enhancing stealth capabilities against enemy air defense systems. The engine is integrated with special materials and techniques designed to minimize radar and infrared signatures. The air intake and exhaust ducts are geometrically optimized to limit radar wave reflection, while the advanced cooling system reduces the temperature of the exhaust flow, making the FX harder to detect. With a projected power output that far exceeds the engines on the current F-2 and F-15J, the FX ensures the necessary strength to meet demanding combat requirements. Additionally, its high reliability and performance make it a formidable asset in modern aerial warfare. The ability to operate in harsh conditions helps reduce maintenance time and increase operational efficiency. The FX is equipped with an active electronically scanned array radar. An electronic warfare says even future hypersonic weapons are on the horizon. Notably, integrating carbon fiber reinforced polymer, CFRP, has reduced weight and improved stealth by minimizing radar detection. The FX aircraft features serpentine air ducts, internal weapon bays, and electromagnetic wave absorbers, all designed to evade enemy radar. Its cockpit boasts a digital interface with a large touchscreen and HUD, giving the pilot a full battlefield view and efficient system control. One standout feature is its adaptive sensor suite, which adjusts radar emissions to avoid detection. Enhanced sensors, including an ASA radar derived from the Mitsubishi F2's JG2, passive RF sensors, and infrared cameras, improve stealth detection. Experts predict its ASA radar will be similar to the APG-81 used in the F-35 Lightning II. To prevent overheating, engineers designed a vapor cycle-inspired cooling system, while Mitsubishi refined the XF9 engine, eliminating extra cooling needs. The FX features a 30% smaller inlet than the GF10 on the F2, enhancing stealth. Thrust vectoring allows high-speed agility and complex maneuvers. Powered by twin XF9 engines, 360 kilowatts, and a 3D thrust vectoring nozzle with 20-degree adjustments, the FX reaches supersonic speeds without afterburners, reducing fuel use and thermal signatures. Specialized materials and optimized air intakes further enhance stealth by minimizing radar and infrared detection. With more power than the F2 and F-15J, it's built for intense combat. Equipped with ASA radar, electronic warfare systems, and optical sensors, the FX excels in targeting and battlefield connectivity. Its primary weapon, the ASM-3 supersonic missile, has two versions, the extended-range ASM-3A and the classified ASM-3 Kai. In July 2022, reports surfaced about Japan and the UK merging their FX and Tempest programs to develop a next-gen fighter. Could this partnership revolutionize military tech? Share your thoughts. Initially, the UK planned to collaborate with France and Germany on the FCS program, but joined Japan and Italy instead due to political and industrial disputes. This alliance strengthens London's role and benefits from Japan's advanced tech. Mitsubishi and BAE Systems lead the project, with IHI and Rolls-Royce handling engines, Leonardo, Italy, managing electronics, and MBDA UK developing missiles. Beyond the fighter, Japan and the UK also signed a deal in 2022 for further defense cooperation. E-Jaguar radar system, a key strategic move. What's your take? Let us know in the comments. The GCAP fighter is about 30% larger than the Eurofighter Typhoon, with a dry weight similar to the F-15 Eagle. Its stealthy design, featuring angular surfaces and lightweight composites, enhances speed, range, and payload while ensuring durability in combat. A standout feature is its internal weapons bay, which maintains stealth by concealing missiles and bombs. It can carry advanced weapons, including hypersonic missiles for high-speed, long-range strikes. With a 50 degrees wing sweep and a wingspan close to the retired F-111, GCAP prioritizes stealth and long-range firepower over extreme agility. Powered by a next-gen Rolls-Royce, IHI, and Avio Aero engine, GCAP boasts supercruise, enabling sustained supersonic flight without afterburners for better fuel efficiency. The engine also reduces thermal signatures and includes thrust vectoring for superior maneuverability. Revealed at the 2024 Fur Air Show, GCAP balances air-to-air and ground attack missions, complementing the F-22. While every partner nation flies F-35B carrier-based jets, except the UK, which operates F-35As, GCAP fills the need for a multi-role fighter with greater weapon capacity. It will integrate domestic and co-developed weapons like the MBDA Meteor, Spear 3, ASM-3 anti-ship missile, and a new air-to-air missile featuring a Japanese warhead, enhanced radio wave seeker, and British-engineered tail. However, its expected speed of Mach 3.5 falls short of the Meteor's Mach 4+. The UK Ministry of Defence plans the Tempest prototype's first flight in 2027, showcasing some GCAP features. However, the full Japan-UK-Italy project won't be operational until 2035. Stealth aircraft development remains slow and expensive. Even the U.S. has paused its 6th-gen fighter program. Could global collaboration revolutionize military aviation? Will we see the ultimate stealth jet soon? Share your thoughts. For decades, commercial jets have remained stuck at 1960 speeds. While modern planes are quieter and more efficient, they haven't gotten any faster. Why? Have we hit a technological wall? Or is something else at play? Boom Technologies aims to change that with the XB. 1. A supersonic jet that could revive high-speed air travel or repeat past failures. Over the Mojave Desert, technology, ambition, and physics collide in a high-stakes test. Aviation advanced rapidly, from the Wright brothers in 1903 to breaking the sound barrier in 1947, then Concorde's Mach 2 cruises by 1976. Yet by 2003, supersonic passenger flights disappeared. Why? Early supersonic jets, backed by governments, ignored economics. The Concorde was loud, inefficient, and costly, burning 1.2 gallons per 7.17 passenger miles and emitting massive CO2. Can supersonic travel make a comeback? New technologies in high bypass engines and natural flow control could make it greener and more viable. The future of flight may be faster than we think.